This is Mr. Kanyile with the VirtualX MasterClass. Continuing with calculus, the part that we're doing is usually at the end of the calculus paper. It's the last part of the calculus paper. It's called the application of calculus. This part also requires your understanding of your grade 11 measurements, because we'll be talking about volumes as well in these sections. And your formulae, you must know your formulae. Because that's why you talk about cylinders, you talk about all the cones and stuff like that. So you must understand, you have a background of that. You must know what is area, what is a volume of any figure. For example, what is a volume? A volume is nothing else but the area of the base times height for every figure. A volume is the area of the base times height. That's what a volume is. If I have a figure like this one, let me just make an example. This is my box. Oops, it looks bad. This is my box. If this is my length, this will be my breadth, this will be my height. This is the front view, this is the side view, and this is the top view. 3D problems. This is length times breadth times height. So if I'm looking for the volume, it will be the area of the base. Area, this is length times breadth. That will be my area times height. Or length times breadth times height. That's what a volume is. I must be able to see those sides as well. When we talk about the surface area of this box, we're talking about the areas of their surfaces. This is where your design comes in. What would be the size of all these surfaces that makes this box? Let's count them. How many surfaces that makes this box? It's this surface. If I'm looking for the area of this part, it is this length times this height from that one. It's this side times this side. It will give me this area. When we talk of the area, it is the area of the base, nothing else. So this whole box, its area will be length times breadth. You concentrate on the base when you talk of the area this box occupies. But when it's the volume, it is the length times breadth times height of this particular box. So the volume of this box will be the length times breadth times height. That's what we call a volume, what it can contain. The volume of this base will be the area of the base, which is length times breadth times height. So if you want to understand the formula for the volume for all the figures, it's just the area of the base times height. In this one, even though it is length times breadth times height, the length times breadth is the area of the base, then times height. That's what the volume is. That becomes important. And when you talk of, let me still continue talking about the volume. If I have this figure, if I have this figure, a cylinder, like the one that we'll be doing with you. If I have this figure here, let me call this cylinder. I want us to look at this cylinder. It might be anything. Let's make use of a tin of fish. How is a tin of fish? It is closed on both sides when you buy it on the shop. But when you get it, this part here, this distance here, will be our height. We'll call it h. But this part which is circular, what is the area of this one? It is pi r squared. This is the area of a circle. It's pi r squared. So when we talk of the volume of this tin of fish, remember what I said the volume is. It is nothing else but the area of the base times height. So the volume here will be equals to pi r squared h, the area of the base times height. The volume here will be area of the base, length times breadth times height. That's what a volume is. It will assist us. But at times we might not only deal with cylinders. If I cut the cylinder, let's do it this way. If I cut it in this way, let me just divide this into 3 parts. These are 3 equal parts. These are 3 equal parts. So this is 1/3, 1/3, and 1/3. Now, if we cut this one out, I just want to talk about the cone. How easy it is to because these formulas were not given in the exam, so you must know them. If I cut this here, now this becomes a cone. It's no longer a cylinder, it is now a cone. If you look at this cone, what is the volume of the cone? So the volume will then be equals to, this is no longer 1, 2, 3 thirds, it is 1/3, 1/3 of the same thing, pi r squared h. So this is how you find the volume of the cone from the volume of a cylinder. So that becomes important. Another important aspect in this section is what we call the surface area. What is the surface area? We're talking about the areas of the different surfaces that forms that particular figure. For example, if we have this box is made out of how many surfaces? It's this one, it's the one at the back, which is 2, it's this one this side, and one at the other end, which is 3, it's the top and the bottom. So it's 1, 2, 3, 4, 5, and 6. It is made out of 6 surfaces. So when you talk of the total surface area, I've got to add the areas of all those 6 surfaces. That becomes important. So when I open this box, I must be able to see this surface, that surface, this surface, all 6 surfaces. I must be able to calculate its areas. The area of this surface will be this part times that part times 2, the other one at the back. The area for this surface will be this one times that one times 2. The area of the top and the bottom will be this one times this one times 2, because there are 2. But at times you'll find questions like a box without a lid. When there is no lid here, there will be no longer 6 surfaces but 5 surfaces. That becomes important. Earlier on, I talked about a tin of fish. I said here at times we'll talk about a box without a lid. So it will be this surface, these 2, and there's 2. There's nothing on top. That's what we mean a box without a lid. But when you look at this cylinder, a tin of fish, it is closed on top, it is closed at the bottom. But when we talk of a drinking glass will be opened on top. Those things are important when you deal with this section. We said a volume is area of the base times height, the one that holds the container that can hold that volume. But how do we determine the surfaces of a tin of fish? How can we calculate? If I want to design that, how will I make those surfaces be like? I know that we set this part here, we call it the height. This will be the height of the drinking glass. This will be our height. We said our area is pi r squared. Right, that's what we know. How can I calculate the total surface area of that tin of fish? Remember this one also, it's pi r squared. This is exactly the same as this one. And how can I find surfaces of this? You can unpack it so that you see it. Now let's do it here so that it will make sense. I'm just thinking of this. It will be something like this. Well, let's explain it to you now. I'm just opening it. I see something like this one and also see something like this. This is how I will go about designing this part. Right, this is how it will look like on paper before I put it together. What is happening here? I've cut this tin of fish here and I've opened it so that this part that was closing the fish inside, it will look like a rectangular in this particular form. But I will also open the top. As you are about to cook the fish, you open it up, you flip it over. So this is what I flipped over in this part. But because it's also closed there and there, these are the 2 surfaces. So this will be the one on top, this one is the one at the bottom. So when I close this, it will give me the design of that fish. So if I push it together and close it here and put it close, it will look like a tin of fish. But there are things that we must take note of. in this, I can see now the surfaces that builds this tin of fish. There are three, 1, 2, 3. These two are the same, and they are circular. These two are what? It's a rectangular. Remember, this is still H. This H is still the same one here. The height of my tin. Oops. This is still pi r squared. This is still the same thing, pi r squared. Right. Now, what do we call a distance around the circle? It is called the circumference. This is the circumference. This distance here is called the circumference. What is the formula for the circumference? It is 2 pi r. Just cut. Forgot the formula.
Yes.
Remember that when I open the tin of fish, I've got to flip it over and flip it down. I will see these two circular parts of the tin of fish of my cylinder when I closed it. What is important is this. We said that this part is the circumference. And the distance around this is called the circumference. And the formula for circumference, it's 2 pi r. This is the formula to calculate the circumference. It's 2 pi r. This circumference is exactly the same as this one. Now watch here. This distance from here up to here, which is the circumference, must exactly be the same as this distance from here to there. Because if I push this side and close it, it should fit. If it doesn't fit, then those distances are not the same. I'm saying this distance, which is the circumference of the circular parts, must be the same distance as it from here to here, so that when I close it, it fits exactly. So we are saying here, this distance from here to here is the same as 2 pi r. This is this distance. Remember, I'm trying to explain the term total surface area. This tin of fish is made out of 3 surfaces. These 2 circular surfaces and these rectangular surfaces. So when we are looking for the total surface area, it will be equals to these 2, which are 2 pi r squared. It's this one plus this one, plus this area here. Remember, I'm talking about the total surface area. What will this area be? It will be this distance times this distance. What is this distance? It is 2 pi r times this one times h. This is how you find the total surface area of a cylinder. Right? This is how you find the total surface area of this particular cylinder. Now, with that background in mind, I want us to look at this question, which was set in November 2008. And for your practice, immediately after understanding this, go and do question 9, which was March 2016. It's asking the very same thing, just change figures there. As we do question 10, November 2008, you go yourself and do question 9, March 2016, if you go to your library. This is a drinking glass in the shape of a cylinder. Remember, we made an example here with a tin of fish. A tin of fish is closed there, it's closed there. That's why we've got 2 circulars here. But in this case, we're talking about a drinking glass. A drinking glass is only closed at the bottom. So you'll have this, but we're not going to have that when you talk of a drinking glass. Keep that in mind. Let's look at what we have here. A drinking glass in the shape of a cylinder must hold. This becomes important. This is the volume. This is the volume that it must hold, liquid when full. So we know the volume. It is 200. Show that the height of the glass can be expressed as H is equals to pi 200 over pi r squared. Okay? We know the volume. We are given the volume. What is our volume in this case? It's 200 mils. show that the height of the glass H can be expressed as this one. Show that this is the height. Okay. We know what a volume is, the area of the base times height. As I explained, whenever you're dealing with the volume, it's nothing else but the area of the base times height. So when you talk of the volume of this drinking glass, the volume will then be, let's write it down, volume is equals to the area of the base times perpendicular height. So my volume, let's write it, volume is equal to, what is the area of the base? How is my base? My base is circular. What is the area of the base? Pi r squared. Pi r squared, that's the area. It will be pi r squared times height times h. This is the volume. This is the formula for the volume. It becomes important. You are not giving this in the formula sheet, so make sure that you understand it. The volume of any figure is nothing else but the area of the base times height. And our height in this particular case is h. The base is circular, so the area there is pi r squared. The question says, show that h is equal to something. So you go back to your grade 8, grade 9 manipulation of the formula. We've got to make h the subject of the formula here. Let's do this thing. Let's put what we know. Do we know the volume? Yes, the volume is 200. That 200 is starting to show up. It is equals to pi r squared h. If I want to make h the subject, I divide it by pi r squared to this side. Also divide by what here? Pi r squared. That goes with that. I'll be left with h equals to 200 over pi r squared. Exactly what the question wanted me to do. Show that h can be expressed in that. You'll find this in a number of times where you express something in terms of something, and in the next question, what you've expressed you'll have to apply. Wherever there's h in the next question, instead of h I've got to put that one. This is what you'll be noticing in all these questions that has to do with maxima and minima. Now let's look at the next question that they've asked. The question says, show that the total surface area, now we're talking about the total surface area of the glass can be expressed as that one. Show that the total surface area of the glass can be expressed as, now the total surfaces of this area can be expressed as that one. Do I know the total surface area of the drinking glass? Remember, this was the total surface area of what? Of this tin of fish. Now we're talking of the drinking glass. So a drinking glass, let me just quickly make an example here. A drinking glass, its surface area will look like this one. Let me just do it here. Remember, this is h this side. This will be 2 pi r the distance, 2 pi r the circumference. It is opened on top, but it's not opened this side. This is pi r squared. How many surfaces do we have here? We've got only 2. Unlike this one where we had 3 surfaces, because it was also closed on top. The drinking glass is open on top, so there is nothing circular on top. It is hollow. So these are the surfaces. So the total surface area of the drinking glass, will be equals to, let me just write it as they've expressed it. The surface area in terms of R will be equals to, it is this part here. 1, unlike this one, there were 2 pi r squared. There were 2 here. In this case, it is only 1, which is pi r squared plus this one, plus, what is this one going to be? It will be 2 pi rh plus 2 pi rh. This is the total surface area that makes this drinking glass. It will be pi r squared plus, there are only 2, 1, 2, 1, 2. Unlike this one, there were 3, 1, 2, 3. Hence, you set 2 of this. Now it is only 1 plus this other one, which is the same as in that one, 2 pi rh. That's what we have. This is what we want to get at the end of the day. Show that pi r squared is equal to, show that surface area is equal to pi r squared plus 400 over r. When I look at what I need to show, do I have h there? I don't have h, but I've got things in terms of pi r and r. Can I express this in that one? Yes, that's exactly what we were doing here. So where there is h, you've got to substitute that one. Then the answer will come into place eventually. Let's try it. Let's try it together. So the surface area will then be equals to pi r squared plus 2 pi r. What is my h that we found? It is 200 over pi r squared. That's my h. It is 200. Okay, then eventually we'll find the solution. Surface area will then be equals to pi r squared. Oops. Plus, let's work it out. This times that, this times that. The pi r will go with pi r. I'll be left with 1 r there. What is 2 times 200? It is 400. Remember, I left with 1 r on this side. This is exactly what this wanted us to find. So it is true that the surface area is 2 pi r squared plus 400 over r. What was important here was to understand that a drinking glass does not have this part, hence the formula will not have that 2. It will exactly with that formula without a 2. That's the key. This was a drinking glass, so it was opened on top. The last question. Hence, determine the value of r for which the total surface area of the glass is minimum. Okay, let me just try and explain that for you. Let me take this out. The question is, hence, determine the value, right? There's only one value, so it's something equal to something. If it was values, we're going to have more solutions. In this case, there's only one value of r for which the surface area has a minimum, of a class is a minimum. If I have a cubic function, because we're dealing with trigonometry, this part is called maximum, this part is called minimum. This section is called maxima and minima. Because we're dealing with calculus, we know something about this position. We know that there is no gradient at this position. In other words, the gradient there is 0. No slope. Gradient is nothing else but a slope. There is no slope at this position. There is no slope at this position. What is a gradient? A gradient is nothing else but a derivative. So a derivative here is 0. So when you differentiate it both at maximum and at minimum, so it doesn't matter whether we use maxima or minima. That becomes our keyword. When you see maxima or minimum, we're going to let the derivative be equal to 0. That's important. Whether we use maxima or minimum, it doesn't matter, because at these points, the gradient is 0. So hence determine the value of r for which the total surface area of a glass is maximum. This is the surface area. They say now it is a minimum. So at minimum or maximum, you let your derivative be equal to 0. So for minimum, we're going to let s prime be equal to 0, because there is no gradient at minimum or at maximum. So those becomes keyword. So when you look at this section, this is always there, and it is the gist of this section, which is calculus, the gradient. We know that this gradient is 0 at this maxima or at minimum. So you'll find those questions at all times. All that you need to do is to let what you've already found there to be the derivative to be equal to 0. Let's do this thing. Now, before I differentiate, let me take this here. Before I differentiate, is this arranged in the form of ax to the power n? No, it is not arranged in that form, because we're doing it in terms of r in this particular case. So this must go on top. Let's arrange it first. This then will be equals to, this one is okay, it is pi r squared plus, take this r on top, it will be r to the, okay. Let me do it correctly. We've got 400 there, r to the power minus 1. This was r to the power 1. So when you take it on top, it becomes r to the power minus 1. This is our surface area. Now let's differentiate it and let our derivative be equal to 0. When you differentiate this one, it will be derivative here, it will be 2 pi r and minus 1 It's gone. Differentiate this one, it will be, oh, it's no longer plus. Minus times this, it will be minus 400 r to the power minus 2. I think that's what we have. I'm letting this be equal to 0, so this will be equal to 0. That's what we have. Remember, we're looking for the value, one value of r, not many. Okay, that's what we have. What do we do now? Okay, let me take this side. It will be positive, so I have 2 pi r is equals to, if I take this side, it will be plus 400, and I'll take this down, it will be over r squared. That's what we have. Remember that I'm looking for the value of r. Let me put all the r's together. So I multiply by r squared this side and multiply by r squared this side, so that this r will go. If I multiply this by r squared, I will have r cubed equals to, I've got 400 to that side. I will divide by 2 pi, so that I will only be left with r. 2 pi. You can work it out in whatever way that you want to work it out. That's what we have. Remember, I'm not looking for r cubed. I'm looking for r. How do I move from r cubed to r? I look for a cube root. So if I'm putting a cube root here, it will be r is equals to, and put a cube root also there to kill this cube form. It will be 400 over 2 pi. So my r therefore will be equals to, you push that in the calculator and you'll find the solution. Let's quickly do it. Where's my cube root? Oh, my cube root is there. Shift cube root. I go inside of, that's a fraction form. Numerator is 400 divided by 2 pi. Where's my pi here? Okay, shift pi, right? This will be 3,99. My r is 3,99. I'm not given digits. Okay. This is the distance, 3,99 centimeters. That's the r that we have in there. Right. The gist here was to understand the word minimum or maximum. That's where you let your derivative be equal to 0. When you differentiate, you follow the rules of differentiation. You can't differentiate in terms of r, and your r is the denominator. You've got to take it up first to be r minus 1. Then you let your derivative be equal to 0. You differentiate until you find the exact value of r. Thank you.